Le Chatelier's principle says that when there's a change to a system, the reaction will shift to reestablish equilibrium. A change can include changes in concentration, temperature, or pressure. So we're going to go through each potential change in concentration, temperature, and pressure that can happen, and how those changes will affect the position of equilibrium, or which way the reaction will shift to reestablish equilibrium. The first change we'll discuss is a change in concentration. When concentration is increased, the rate of a reaction will increase in that direction, so the reaction will shift to the opposite direction to reestablish equilibrium. When concentration is decreased, the rate of the reaction will decrease in that direction, so the reaction will shift toward that direction to reestablish equilibrium. For example, if reactants are added, the reaction will shift right toward the products to reestablish equilibrium, and if products are added, the reaction will shift left toward the reactants to reestablish equilibrium. If reactants are removed, the reaction will shift left toward the reactants, and if products are removed, the reaction will shift right towards the products. So think of it like a seesaw. One side will be heavier and weigh the seesaw down, so the reaction will shift to the opposite side to reestablish equilibrium. The next change we'll discuss is a change in temperature. When temperature increases, it increases the heat in a reaction, and the reaction shifts in the opposite direction to reestablish equilibrium. When temperature decreases, it reduces the heat in a reaction, and the reaction will shift toward that direction to reestablish equilibrium. The tricky part here is that heat is on different sides of the reaction, depending on whether the reaction is exothermic or endothermic. If the reaction is exothermic, heat is exiting the reaction, so it's on the product side. And if a reaction is endothermic, heat is entering the reaction, so it's on the reactant side. So for exothermic reactions, an increase in temperature will shift the reaction towards the left to the reactants, and a decrease in temperature will shift the reaction to the right towards the products. For endothermic reactions, an increase in temperature will shift the reaction to the right towards the products, and a decrease in temperature will shift the reaction to the left towards the reactants. So just be sure you have the heat on the correct side of the equation before trying to figure out which direction the reaction will shift to reestablish equilibrium. The last change we'll discuss is a change in pressure for gases. When the volume of a container is decreased, gas particles have less space to move around and they bump into each other more, so the pressure increases. An increase in pressure will cause the reaction to shift in the direction with less gas particles to reestablish equilibrium. When volume is increased, pressure decreases, and a decrease in pressure will cause the reaction to shift in the direction with more gas particles to reestablish equilibrium. In the example, A plus B yields 2C plus D. All of the substances are gases, and there's a total of 2 moles of gas on the reactant side and 3 moles of gas on the product side. If the volume decreases and pressure increases, the reaction will shift to the side with less moles of gas. And if the volume increases and pressure decreases, the reaction will shift to the side with more moles of gas. In the next example below, we have the same substances, but now one of them is a solid. That changes the moles of gas on each side of the reaction. So now we have 2 moles of gas on each side. And since the moles of gas on each side are the same, there will be no shift in equilibrium when pressure changes. The last thing you need to know about Le Chatelier's principle are some changes that don't affect equilibrium. The addition of a catalyst and changes in surface area change the rate of a reaction, but in both the forward and reverse directions. Since reaction rates are lowered in both directions, it won't cause a shift in equilibrium in either direction. The other change that won't affect equilibrium is the addition of inert or noble gases, or really any gas that doesn't react with the system. Gases that don't react don't affect the reactants or the products, so they also won't cause a shift in either direction.